Our 10.5 volume of solids. Alright, so we're going to be able to calculate the volume of solids. We're going to use that formula page, that's just a few pages back in the notes, to be able to calculate the volume. But before we do that, a couple things. Volume is the measurement of the amount of 3D space. I originally just had space there, but it's important that you understand it's a three-dimensional amount of space. So it's a measure, we usually do it in cubic units. Well, we always do it in cubic units. And so you can imagine, you know, we're really asking, like, how many little cubes can we fit inside a figure? So, for example, in this first one, when we find out the volume of this thing, we're asking, you know, if we were to kind of like melt this down, how many cubic centimeters, how many 1 by 1 centimeter cubes could we fit inside this thing? That's what we're really asking. Okay, and on the formula page, you may want to make a note of this. For the prism, I said that the volume is length times width times height. And that's true, but it's only true for rectangular prisms. Another formula you may want to add there is that the volume equals the base area times the height. Base area times height. That's really important, because when you're dealing with a triangular prism like here, this won't work anymore, but this will. Base area times height. Where, see, in a rectangular prism, length times width is your base area, but here it's a triangle, so the base area is a little bit different. So let's talk about that. First, it looks like we're going to need to get a couple more numbers to get this base area. So let's copy down the formula real quick. It's volume equals base area times the height. Well, they didn't give us all the dimensions here, but they did tell us that this hypotenuse is 13. So I know that this hypotenuse is 13 as well. And this is a triangle that we've seen several times before. It's a Pythagorean triple, and the triple is 5, 12, 13. So we know that's 5 centimeters as well. So if that's the case, when they ask for the base area, the base is the non-triangular part. Or I'm sorry, the non-rectangular part. So they're just really asking what's the area of this triangle. We're going to find that area, and then we're going to multiply it by the height of this figure. And 10 here would be the height. Imagine if you were to take this triangle and stand it up upright. This would be the bottom, this would be the top, and this would be the height. And so this here is the height of the prism. And so sometimes we'll put a little P here for meaning height of the prism, just so we know what we're talking about. So, volume equals the base area. Well, the base area is a triangle, and triangle is 1/2 lowercase b times the height of the triangle. And then this whole thing is going to be times the height of the prism, right? All right, well, let's just plug it in. I think we got all the parts we need here. So we got 1/2 the base of the triangle. Well, I'd call that 12. And the height of the triangle I would call 5. See, base and height of the triangle. And then we're going to multiply that by the height of the prism, which we said earlier is this distance, 10. And so there, we've plugged everything into our volume formula. Now it's just about calculating it all out. Pretty simple to calculate, though, because half of 12 is 6, and 6 times 5 is 30. So we really have 30 times 10. And 30 times 10 is 300. Now again, we're talking about cubic units here, and we're talking about centimeters, so this is going to be 300 cubic centimeters. Alright, so that means that if I had little 1 by 1 by 1 centimeter cubes, I should be able to fit exactly 300 of them in this space. Now I know they wouldn't fit perfectly because, you know, a cube may not fit inside a triangle, but the idea is, like, if I melted them down, they'd all fit in that space perfectly. So we have an exact amount of volume. Okay, got a couple problems here for you. Now we're talking about cylinders, so if we take a look at that cylinder page, we find that it's, or on the formula page, sorry, we find that the formula for a cylinder is actually very similar to that of a prism, in that it's the base area times height, only that the base area is just a circle, so it's the area of a circle, so it's pi r squared times the height. So, pretty straightforward. We're going to just plug in our values. We have a radius, and the radius is always referring to the radius of the base. And we have a height that goes straight up and down. It could go along the edge, it could go along this edge, or it can go right to the center. It doesn't really matter. That's all the height. So the volume here is going to equal pi times a radius of 4.6 squared times a height of 12.4. Pretty easy. If you were to multiply those things together besides the pi, you'd get an exact answer of 260, that's a 6, 2.384 pi, and this is in meters cubed. And then if you were to actually multiply it all by the pi, so that you can get a rounded decimal answer, you'd get that the volume is approximately 824.3 cubic meters. And so either one of those could be correct, depending on what version they're asking you for, whether they're asking you for an exact here or a rounded here. Okay, so I'm going to let you guys kind of take a look at part B here and see if you could figure it out. Remember, though, the volume formula, I'm just going to write it up here, is pi r squared times the height. So think about what your radius is, think about what your height would be here. This is just a cylinder turned on its side, and they don't give you all the information. They just give you this diameter and this diagonal here, but it's enough to calculate all the parts. Let's think about it, and then I'll explain it in just a second. Okay, so hopefully you realized that the radius is this distance here, which is half of the diameter, so that'd be 2.5 inches. And we have the same 5, 12, 13 triangle here as we had right above. Let's see the 5, 12, 13, 5, 12, 13. So this distance here has to be 12 inches. Well, that's enough to calculate the volume. So volume equals pi. The radius is 2.5 squared. The height we now know is 12. So in exact terms, 2.5 squared times 12 is 75, so we could say that's 75 pi cubic inches, and then if we wanted it rounded, that would be 235.62 cubic inches. Again, both those answers are correct, depending on which one they asked for. All right, so the next one here is asking for you guys to find the volume of an oblique cylinder. Now, I'm going to let you guys know a little secret here. It seems as though, because it's all kind of slanted like this, that maybe we would need a different formula. But that's not true. It's still just the same formula we've been using, pi r squared times the height. And the height is always straight up and down, so this 9 yards is the height. And the radius is still the radius of the base, so I think you guys can do this one pretty easily. Even though it looks different, there's really nothing different about it as long as you pick the right height, which is always perpendicular to the base. Go ahead and give it a shot, and then I'll let you guys unpause it and check your answers in a second. Okay, so 4 was your radius, 9 was your height, so 4 squared is 16 times 9 is 144 pi cubic yards. If you multiply out the pi, you get 452.39 cubic yards. So exact decimal, there you go, we're ready to go to the next page. All right, now we're talking about a different shape here. This is talking about a pyramid, so let's read what it says. It says, Andrew is making a plaster model of the food guide pyramid for a class presentation. The model is a square pyramid with the base, and that's a lowercase b, so it's just talking about one side here. So they're just talking about this distance is 12 inches. And a height, so remember height is this distance straight up and down. Maybe it'll look better if I do it like this. Height is 15 inches. Okay, find the volume of plaster needed to make the model. All right, well, we need a volume formula for a pyramid, which we do have. The volume formula for a pyramid is 1/3 base area times height. So this base area is probably what we're going to need to focus on first. So let's just go ahead and start writing it out as volume equals 1/3. And what would be this base area? Well, the base area is the area of the base. And this, they told us, was a square pyramid. So that means the base is a square. So to find the area of a square, you just take the side and you square it. So 12 squared is 144. So base area is 144. And then we're going to multiply that by the height, which they also give us is 15. And so we could just multiply this all together, and we get 720 cubic inches. You can check it in your calculator, make sure I did it right, but that would be the volume of plaster needed to make this pyramid. All right, once you take a look at this, and we kind of have a clue already from the volume formula for a pyramid, but let's say we have a cone with some radius, and it's inside a cylinder with the same radius. So the bottom would be touching perfect. But my question is, what space, oh, and they have the same height too. What amount of space would the cone take up of the whole cylinder? So what do you think? Do you think it's like 1/4, 1/3, 1/2, 2/3? How much space of the cylinder will the cone take up? And it is actually one of these four. So think about it and then select the answer you think is the best. Okay, well, if you looked at the formulas, you notice that we're seeing this pattern of 1/3. So a pyramid takes up 1/3 of the volume of the same base that's a prism, and so a cone actually takes up 1/3 of the volume of the same base that's a cylinder. So the volume formula for a cone is volume equals 1/3 base area, but now the base area is always a circle, so we'd say pi r squared times the height. That's all there is to it, so we're just going to plug in some of the numbers they give us here and calculate some volume. So let's go to the first one, example 4a here. These may be hard to read, but these are both 8 inches, so that means that when I go to plug this in, my radius is 8 and my height is 8. So volume equals 1/3 pi, the radius is 8 squared, times the height is 8. So if I was to multiply all that out without the pi in exact terms, I would get 8 squared times 8 is 512, so 512 over 3 pi, and this is all in inches, so that would be cubic inches. So there's the exact. If I plug that in my calculator and round, I'd get 536.17 cubic inches, and so either one of those could be correct, depending on what form they're asking for. All right, let's do one more together, just so you can kind of see, because this one is pretty tricky. Maybe really hard to write this one in exact terms, but I think we could do it. So one thing I'm going to do is I'm going to kind of redraw this triangle in red here so you could see it. And they're saying that this angle here is 48 degrees. That's what this arrow is supposed to be pointing to. 48 degrees. And all they give us is this height here. And remember, to find the volume, we need to do 1/3 pi r squared times the height. So we need the radius. We have the height. That's nice. It's 10 inches. But we need the radius to find it. So we need this distance. So let's just go ahead and label that r. And let's think about how could we use this angle and this height to find that. Well, this is a SOHCAHTOA problem. Look, we have the opposite over here, it's 10 inches, and we have the adjacent here, it's the radius. So if I was to go to write this out, I could say that the tangent, because the tangent uses opposite and adjacent, the tangent of 48 is equal to the opposite, which is 10, over the adjacent, which is r. Solve for r, and I get 10 over tangent 48. Okay, well, I think we're ready to give this thing a try. So if I go to plug this into my formula, it looks like this. 1/3 times pi times a radius of 10 over tangent 48 squared times a height of 10. Now, this is just plugging it all in exact because I wanted to show you what it would look like. This is just going to be kind of real nasty. If I wanted to plug this in exact terms, I would simplify everything I could. So let me show you what it would look like in exact. But I think that most of the time for this type of problem, you would just be plugging things in and then give me a decimal answer. But I just want to show you how you could simplify this in exact terms. So let's look at everything that's on top. I have a 1, a pi, a 10 squared, and a 10. So 1 times pi is just pi times 10 squared times another 10. That's like 10 cubed. So that is 1,000 pi on top. Okay, so that's not too bad. On bottom, I have a 3, and I still have a tangent 48 that's being squared. So you would have to write it like this. And that's kind of as simplified as you could write that. So it's real nasty. I don't think you would ever have to use that, but in upper calculus, or in upper mathematics, and especially in calculus, sometimes we need things in exact form, and we need to keep it that way. So I'm just showing you how you could. But anyway, you'd be plugging this in to your calculator, and when you do that, you would have approximately 848.99 cubic inches. So really close to 849 cubic inches. And that's a fine answer. That's as close as we can get just because our exact answer is so funky. We got weird numbers here with the pi, and we're also going to get weird numbers here with the tangent 48. So it makes sense for us to just go ahead and leave it in decimal form. Okay, one last problem. I think you guys can do this one on your own. One last one for cones, that is. So once again, I'll write the formula. It's volume equals 1/3 pi r squared times the height. I think you guys can do this one. Just plug it in, and you get the volume. Go ahead and give it a shot, and then unpause it when you're ready to check your work. Okay, even though it's kind of an oblique cone, right? It's not centered. All the same rules still apply. It's still 1/3 pi r squared times h, where r is 8.6. and the height is 12, and so you just plug that in. If you plug that in without multiplying the pi out, you get 295.84 pi cubic inches, and then if you multiply the pi out, you get approximately 929.41 cubic inches. So there we go. We found the volume of cones. Let's go on to the next thing here. Ooh, now we get to talk about spheres. So in the formula page, we talked about that the volume of a sphere is 4/3 pi r cubed. It's pi r cubed. So really all you need for this is the radius. So in this formula right here, they actually, or in this picture, I mean, they give us the radius right here. It's 24 inches. So let's go ahead and just plug that in. It'd be 4/3 times pi times 24 cubed. Well, I mean, this is just a matter of going to your calculator, doing 24 cubed times 4/3, and you would get 18,432 pi cubic inches. And then if you wanted to round that to the closest decimal, it would be about 57,905.84 cubic inches. All there is to it, just plugging it into the calculator. Now, something about this one that I would talk about is 24 inches is the same thing as 2 feet. And so it might be more reasonable to give us an answer in cubic feet. So this same thing that is 18,432 pi cubic inches, what would it be in cubic feet? Well, I'll do that in red here real quick. Remember, it'd be 4/3 times pi times the radius, which is now 2 feet cubed. 2 cubed is 8. 8 times 4 is 32. And so the exact answer of this would be 32 pi over 3 cubic inches. Now that might be a more reasonable answer, right? It might be a little bit easier to deal with this number than this gigantic number. So just showing you, there's sometimes they'll have you convert, and it's not that bad. Okay, I think you guys can do part B on your own, but I am going to help you start. The way we're going to start this is they only give us the C for circumference. So that's the circumference of, and that's what we call a great circle. Actually, it's a circle that goes right through the center of a sphere. So what's the circumference equal? Well, the circumference, remember, is equal to this little formula, 2 pi r. Well, if I wanted to find just the radius, then I'd have to divide both sides by 2 pi. And so now I have the radius is equal to 36 over 2 pi. And I could take a 2 out of both of those, leaving me with 18 over pi for my radius. Okay. This is where it can get a little funky, especially if you want to put it in exact terms. But I want to let you just try and play with it and see if you can get to the exact answer. And if you can't, no worries. I'll show you how to do it in a second, but I want to give you a chance to just play with it and see. And I'll put the answers up in just a second. Okay, so now you've had some time to kind of play with it. Here's what I did. So I said we knew the radius was 18 over pi, and the volume formula is 4/3 pi times the radius cubed. Well, I rewrote this. What does this really mean? Remember, everything that's being multiplied goes on top, everything that's being divided by goes on bottom. So 4 times 18 cubed times pi is what would be on top, because the 4, the pi, and the 18 cubed are all on top. On bottom would be this 3 and the pi cubed. Well, that means one of the pi's up here is going to cancel out with one of the 3 pi's down here. So you're left with 4 times 18 cubed divided by 3 times pi squared, which ends up being just this, 7,776 divided by pi squared, which if you plug in your calculator is approximately 787.87 cubic centimeters. Okay, that's the number we're looking for. This is the exact answer. We just wouldn't typically leave it with the pi on the bottom like that, but it's okay if you leave it inexact. If they ask for it, you can. All right, this last one says, find the volume of a hemisphere if the great circle's diameter is 4 feet. Now, again, the great circle is just the circle right in the center. So if the diameter of the whole great circle is 4 feet, then that means the diameter of the sphere is 4 feet. That's all it really means. So that means that the radius is 2 feet. And that's all we really need for this. Now, it's the volume of a hemisphere. A hemisphere is half of a sphere. So the volume of a sphere is 4/3 pi r cubed. But we want half of that, so I'm literally just going to multiply it by 1/2. So let's plug in what we got here. This would be 1/2 times 4/3 times pi times the radius, which we now said is 2 cubed. Simplify that. We can actually just multiply straight across. So we have a 4 times a 2 cubed. 2 cubed is 8, so 4 times 8 is 32 pi over 2 times 3 is 6. This reduces, we can reduce this to 16 pi over 3. And we can also plug that into our calculator to get a decimal answer. So this would be 16 pi over 3 cubic feet, which is approximately 16.75. Actually, I'll say 7.6 because that would round up cubic feet. Okay, there we go. All right, let's go on to the next page. All right, all that's left is the summary. I want you guys to think about this one. It says, explain which volume is greater, a sphere with a radius of r or a cylinder with a radius of r and a height of 2r. Let me kind of sketch these things for you so you have an idea. So you have a sphere. I'm going to do my best to kind of draw a sphere here. Maybe I could draw that part in. With a radius of r. Or you have a cylinder that also has a radius of r, but the height here would be 2r. So which one would have the greater volume? Let me draw that radius a little bit better. Which one of these would have the greater volume? Well, I would recommend using the volume formulas. Plug in a 2r for height and r for radius for the cylinder, and plug in just an r for volume, and see if you get some type of algebraic expression that's similar, and see from that you could figure out which one would have to be bigger. So just something to think about, a little way of using algebra to compare volumes. Kind of a fun problem. All right, see you guys in the next video.